Welcome to question 6 of the 2019 Mathematical Methods Exam 1 for the Northern Hemisphere. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. For question 6 we're told that Jacinta tosses a coin 5 times. For part A, assuming that the coin is fair and given that Jacinta observes a head on the first 2 tosses, find the probability that she observes a total of either 4 or 5 heads. So to obtain a total of either 4 or 5 heads, when we know the first 2 tosses were already heads, then we know that we need 2 or 3 more heads from the remaining 3 tosses. So to calculate that, we can identify that this is a binomial distribution, with the probability of success being a half, because it's a fair coin. So therefore the probability of obtaining a head is going to be 1/2, and the probability of not obtaining a head, or instead obtaining a tail, is also 1/2. So the first case we'll consider is when we take 3 remaining tosses and we have 2 of those being a successful head. So it's going to be 3 choose 2 times the probability of obtaining a head to the power of 2, because that's the number of heads that we require. Then we multiply that by the probability of failure, which is also a half, raised to the number of failures, and in this case it's 2 heads and 1 tail, so the number of fails or failures is 1. We then also add on to that the case where we get 3 more heads from 3 tosses, which is going to be 3 choose 3. Then it's the probability of obtaining a head, which is half to the power of 3, and then the probability of failure to the power of 0. So our job now is to evaluate and simplify that expression. So the first thing we need to do is we need to look at 3 choose 2, and we should recognize that there's 3 ways that that can happen. So this is going to be 3 multiplied by 1 on 4 multiplied by a half. So that's that first expression we have. And then we add on to that 3 choose 3. Well, there's one way that can happen. So we're going to have 1 times, and then it's a half cubed, which will be 1 divided by 8. And then we also have 1/2 to the power of 0 is simply 1. So that would be multiplied by 1 at the end. So evaluating these fractions that are multiplied and added together, we'd have 3 times 1 times 1 over 4 times 2 is 8. So this first expression here is just 3 on 8. And then we add on to that 1 times 1 on 8 times 1, which is simply 1 on 8. So simplifying that, we have 3 on 8 plus 1 on 8 is 4 on 8, and 4 on 8 is simply 1/2. So that is the answer to part A of this question. From the examiner's report, we can see that their method of solving this was similar to the one that we did on the previous slide, and they also said the use of a tree diagram or some other appropriate method was also accepted for that question. For part B, we have Albin suspects that the coin Jacinta tossed is not actually a fair coin, and he tosses it 18 times. Albin observes from the 18 tosses that 12 heads appeared. Based on this sample, we want to find an approximate 90% confidence interval for the probability of observing a head when this particular coin is tossed. And we're told to use the Z value of 33 on 20 to do that. So an approximate 90% confidence interval is calculated as follows. We'd have p hat, which is the sample proportion, minus the Z value, in this case we've been told to use 33 on 20, multiplied by p hat, 1 minus p hat, divided by n. And then the upper interval is the same thing but with a plus there. So now that we know how we're going to construct the 90% confidence interval, we want to just calculate a couple of things. The first one being is p hat, which is going to be 12 heads which were observed out of a total of 18 tosses, which simplifies to 2 on 3 as a fraction. So that is the proportion of heads that was obtained when this coin was tossed 18 times. The next thing that we can calculate just to make our life easier is what the value of p hat 1 minus p hat divided by n is. So in this case we would have the square root of, and p hat is 2 on 3, so we have 2 on 3 multiplied by 1 minus p hat is 1/3, and then that is divided by n, which we know is 18, because that's the number of tosses that was in this question. So then we just want to simplify that down slightly. So this is going to be the square root of, and 2/3 times 1/3 is 2 on 9. And then instead of dividing by 18, I'm going to multiply by the reciprocal. So this is technically 18 over 1, so we're going to multiply by 1 on 18 in there. So when we go to evaluate that, we could just simplify down this slightly. So 2 and 18 could be simplified by cancelling a common factor of 2. And we would then just be interested in the square root of 1 on 9 times 9 is 81. So this just simplifies to the fraction 1 on 9, because the square root of 1 is 1, and the square root of 81 is 9. So therefore, our confidence interval becomes p hat, which is 2 on 3, minus 33 on 20, times, and the square root of p hat times 1 minus p hat over n, we worked out before was simply 1 on 9. So we're going to have 33 on 20 times 1 on 9. And then we also have, for our upper bound of this interval, p hat, which is 2 on 3, plus 33 on 20, multiplied by the same value of 1 on 9. And now our job is to simplify that as much as possible. So we can spot here that 33 and 9 both share a common factor of 3. So this could be 11 and that could be 3 down there. And the same thing would happen over here. This would become 11 and that would become a 3. And now our job is just to simplify down this confidence interval. So therefore, we're going to have our confidence interval is 2/3, which is the same as 40 on 60. And hopefully you'll see in a minute why I wanted a common denominator of 60. And that's because we're about to subtract off that 11 times 1 is 11, divided by 20 times 3 is 60. And then we just have on the other side 40 over 60, which is our p hat value, plus the same value of 11 over 60. So therefore, this confidence interval is going to be 40 subtract 11 over 60, which is going to be 29 over 60, comma, and then we have 40 plus 11, which is 51 out of 60, and that's an interval, so I still need the brackets around that. And that is our answer to this question. Now, some of you may have spotted that one of those fractions can simplify. So 51 over 60 is actually 17 out of 20. So you could also have given the answer 29 out of 60, comma, 17 out of 20. And the examiner's report actually accepts both of those. Another interesting thing to note for this question, although it definitely wasn't required as an answer, is that 1/2 is actually contained within this interval. And essentially what that means is that that could still be a fair coin, because we're 90% confident that the true proportion of heads obtained by this coin is somewhere between 29 on 60 and 51 on 60, and 1/2 is contained within that confidence interval. So it's not quite enough to refute the claim that it's not a fair coin, as the proportion of a half does exist within that 90% confidence interval. Again, that wasn't required for the question, but it's just something interesting to note based on how that question was worded. So from the examiner's report, we can see that they quoted their final answer as a common denominator over 60, but because it's just as acceptable, you could also have written that second fraction here, instead of being 51 on 60, it could have been 17 on 20.